Hi everybody. This is a little tutorial about how to use your solar system data page on page 15 of your reference table. So if you turn to page 15, you're going to see this chart in the bottom portion of that page. This will give you some quick references to what's going on in our solar system. First, starting with celestial objects. From the sun moving out, this shows all the objects or the major objects in our solar system, Mercury being the closest planet to the sun, Neptune being the furthest away. And then the very last thing here is Earth's moon, and I'll give you some data on that as well. The mean distance from the sun in kilometers, again, Mercury being the closest, has the smallest distance to the sun in millions of kilometers, and Neptune being the furthest has the greatest distance in millions of kilometers. The period of revolution, this is how long it takes for that planet to go around the sun. It takes 88 days for Mercury, and you'll notice that from Mercury, Venus, Earth, and Mars, these are all measured in days. These are Earth days. And then the unit changes when you hit Jupiter, and these are all measured in years. The period of rotation at the equator is basically how long a day is on this planet, and these are all measured in Earth days. You'll see here that Earth is pretty close to 24 hours. Venus is, for it to complete one rotation, it takes 243 Earth days. The eccentricity of orbit. Remember, if the number is greater, that means that the orbit is more elliptical. So Mercury has a very high eccentricity compared to the others. That means it has the most elliptical orbit. The equatorial diameter is how big this planet is at the equator, and that is measured in kilometers. The mass of the planet compared to Earth. So, for example, Saturn is 95.16 Earths. And the density of the planet in grams per cubic centimeter. Just to kind of highlight something else on this chart, the first four planets here, Mercury, Venus, Earth, and Mars, these are known as the terrestrial planets. And they are called the terrestrial planets because they are rocky. And because they're rocky, they have the higher densities. And as we move down the chart, we see here that the Jovian planets are the outer four planets, and they have lower densities, and that's because they are made of gas. So again, the four inner planets, the terrestrial planets, very rocky, higher densities, and the four outer planets, the gaseous planets, very low densities.
Did you finish it?